Hey everyone, Advent of Code 2015, this is day 13. Alright, we're going to get started here. Day 13, nights at the dinner table. In years past, the holiday feast with your family hasn't gone so well. Not everyone gets along. This year, you resolve will be different. You're going to find optimal seating arrangement to avoid all those awkward conversations. Oh, I bet the table is going to be fucking huge. Okay, you start by writing up a list of everyone and the amount. You started by writing a list of everyone you invited and the amount their happiness would increase or decrease if they were to find themselves sitting next to each other in person. You have a circular table that will be just big enough to fit everyone comfortably, and so each person will have exactly 2 neighbors. For example, suppose you have only 4 attendees planned, and you calculate their potential happiness as follows. Alice would gain 54 happiness units sitting next to Bob. Alice would lose 79 happiness units by sitting next to Carol. Alice would lose 2 happiness units by sitting next to David. So on and so forth. Then, if you seat Alex next to David, Alice would lose 2 happiness units because David talks too much. And David would gain 46 happiness units because Alice is such a good listener. For a total change of 44. If you continue around the table, you could then seat Bob next to Alice. Bob gains 83 and Alice gains 54. Finally, seat Carol, who sits next to Bob. Carol gains 70, Bob loses 7. And David, Carol gains 55 and David gains 41. The arrangement looks like this. Okay. David, Alice, Bob, Carol. After trying every other seating arrangement in this hypothetical scenario, you find that this one is most optimal, with a total change in happiness of 330. What is a total change in happiness for the optimal seating arrangement of the actual guest list? Okay. Get your puzzle input. So it's going to look like, okay, so we have 1, 2, 3, 4, 5, 6, 7, plus Alice is 8. Looks like we have 8 guests. Okay, well, that's not that big. But before I do that, let's take this sample input. I'm just going to go ahead and copy and paste this in as a test case. So we have text. Expected output is going to be, what is the total change in happiness for the actual, okay, total change in happiness is 330 for this example. 330. Okay, so now, class, let's do struct. No, struct, let's do guest. And the guest is going to have a name. Var name is going to have an array of, should have an array of, happiness. Well, what should I call this variable? So this is going to be the variable that represents the happiness that this guest receives if they sit next to a certain person. So it's going to be, something, and it's going to be a string, which is going to be their name. And then it's going to be, string, which is going to be their name, and an integer, which is going to be their difference in happiness. So, by sitting next to them. So what should I name this? This should be happiness score, friend score. Let's call it friend score, right? So if Alice is sitting next to Bob, her friend score is, her friend score for Bob is 54. And her friend score for David is -2. Okay, so I think that should work. I'm going to go ahead and we're going to create an init. Name, string. So this is interesting. How am I going to initialize this? I guess there's going to be a step where I need to compile the actual, I need to compile the friend score from a list, right? So there's going to be, so if I divide this up by lines, Alice has 3 lines. So I'm probably going to have to pass in an array of lines to process. Or maybe this is something that needs to be built up over time, right? So we create the guest from a set of lines or something. Okay, well, let's just start with this. I'm going to give this an equals empty dictionary, init name, and it's going to be self.name equals name. Okay, so now let's do a static func. Trying to decide how I want to model this. If I want to require that let's just take an array of inputs, right? We'll do a static func from lines. Okay. Lines is going to be an array of string. And so from these lines, we need to parse it out. No, actually, I have a better idea. Before we get to that part, we need to parse these into rules. So I'm going to say struct rule, and a rule is going to have a var what should I call this? The subject guest. That's going to be a string. Subject guest name, let's say. Subject guest name, var happiness change. That's going to be an integer. And var, and this is going to be an object, or an object chain, guest name. So I'm calling it subject and object because that's in grammar. It's Alice is the subject of the sentence. By sitting next to Bob is sort of, maybe there's something else that's called that, but I'm just going to go with that. And so we want to initialize this from a descriptor, and the descriptor is going to be that line of text from the puzzle input. So in this case, the descriptor would be, we need to create a regular expression. So we're going to do let groups. Okay, so now this is probably going to be a pretty simple regular expression because it's pretty normalized. We have a person's name, the words would gain. Oh, we have either would gain or would lose. So we need to get this word. Is it gain or lose? And then this number, and then happiness units by sitting next to, and then the other person's name. Okay, so let's go to debugx. Debugx.com. Okay, what's going on? Debugx.com. There we go. Okay, Alice would gain. Oops, nope. Alice would gain blah blah blah. So the first capturing group is going to be going to be what's the word for, what's the shortcut for a letter? Digit. Here we go. A word character. It's \W. Okay, let's just go with that. \W plus. Right? So Alice would gain 54. Okay. And then there's going to be a space, would, and this is either going to be either gain or lose. Would one of gain or lose. There we go. Gain or lose, space, and then there's going to be another capturing group, and this is going to be digits plus. There's going to be at least one digit. Lowercase d. Yep. Okay, so we have word character. Alice would gain 54 happiness. Oops. Plus has got to go there, not on the outside. Okay. Happiness. Oh, I see. I have an extra HAPPINESS units by sitting next to another word character. There. Alice would gain 54 happiness units by sitting next to Bob. Next line. Let's try lose. There is a period at the end. So let's do a \period. There we go. Alice would lose 79 happiness units by sitting next to Carol. Okay, so this is going to be our regular expression. This is it. Okay. So we're going to do let groups equals regex parse. I'm going to have to double escape all of these, little escape, these backslashes. Okay, backslash. Okay. So groups. And then, so the first group is going to be the name. Let name equals guard let groups dot count dot length. No, not count. Oh, no, I need to actually then descriptor. Groups dot count. It's going to be that. Guard let groups. Guard groups dot count is greater than or equal to 1, 2, 3, 4. Okay, else fatal error. The puzzle input descriptor, I'm going to wrap this in quotes, single quotes, just for my own sanity, is invalid. Okay, that should never happen because I trust the puzzle input. But, you know, if my regular expression is wrong, there's something wrong with it, then I would want to know about that. Okay, so then once we have that, we can say self.subject guest name equals groups 0. And then we're going to do let happiness sign. So this is going to be either gain or lose. Is going to be groups 1. And self.happiness change equals groups 2. And then multiplied by, or let's do happiness sign, let happiness multiplier. So if it's going to be lose, then we need to multiply it by -1. Multiplier equals happiness sign. If happiness sign equals gain, then the happiness multiplier is 1. Otherwise, it's going to be -1, because we can assume that it's going to be lose. Times happiness multiplier, right? Okay. Oh, that needs to be parsed as an integer first, right? So far, so good. It's going to say you didn't initialize object guest name. Yep. Self.object guest name equals groups 3. Okay, that should do it. Yep. Okay, great. So this means that I can transform my input into an array of rules. So that means I can take my array of rules and turn it into a list of guests. So for each guest, I'm going to have a set of rules. So init, here we go. Init. I'm going to do static func from rules. Is going to be an array of rules. And it's going to return an array of guests. So we're going to do rules dot group by. Is there a group by? Okay. I'm going to do var guest names. Guests equals. It's going to be a string. That's going to be the guest name, and then an array of rules that assign to that subject guest. So, and we're going to initialize it as an empty. Let's do that. Oh, no, wait a second. I got to do that because I already put the equal sign. All right, so we have our guests, and now we're going to loop through all the rules. So we're going to do rules.for each, and we're going to say rule, and we're going to say guests if guests dot rule dot subject name equals nil, and we're going to say guests rule dot I have an idea. No, all I want to do at the end, I want to set the guests rule dot subject guest name equals new rules, like cumulative rules, right? So then var cumulative rules equals, so let's do var existing guest equals rule guest rules equals guests rule dot subject guest name, or an empty array, and existing guest rules dot append rule, and then existing guest rules. Oh, no, actually we should start with cumulative rules, right? There we go. I think that should create a list of guests, and then we're going to return guests. Return. And so then we don't want to return that. We want to, for each guest on the string. Okay, so we go guests dot for each key. So that's going to be guest name and rules. So now we're going to say, no, do we want to map that? I think we want to map it. Yeah, that's what we want to do. We want to map this. It's not a for each, it's a map. So this is going to return a guest. a fully formed guest object. And this is actually just going to get returned because that'll be our array of guests. So we want to say guest, var guest equals guest name, guest name. Okay. And then for the guest, we want to guest.friend score. So for each friend, we want to, okay, var, shoot, how do I want to do this? Guest, let's start with this, rules.for each. Do I want to map the rules? I do it, yeah, I guess I want to map the rules, right? Because there's only going to be one rule for this guest. There's going to be one rule for each pairing, right? So that's what I want to do. I'm going to do var pairings. And that is going to be rules.map rule. And I want to return the subject guest. No, the key is going to be I know. Here's what I'm going to do. Rules.for each rule. So for each rule, it's going to be, we're going to have guest dot friend score, and then the name is going to be rule dot object guest name equals, and the skis, the happiness score is going to be rule dot happiness change. There, that's it. And then we return guest. Right? So this is going to mutate the guest struct, and it's going to eventually return the guest, and that should do it, right? Build succeeded. Okay, so now we have our array of guests. So I can take, so first thing I'm going to do is I'm going to start from my puzzle input. I'm going to take my let lines. So we're going to do let rules equals input dot lines dot map rule dot init. And then we're going to do let guests equals, is going to be guest dot from rules. And so now we have our list of guests. So from there, now all we have to do is design a table. So our guest is going to be an array of guests. So we need to find all the permutations of this guest list. So guests.permutations. Permute. Okay. Takes any collection of T and returns an array of permutations. Okay, so this is what I want. I think I want to make this generalized. I'm going to copy this for now into my new puzzle input. I'm going to move it down here to the bottom. But at some point, I think I want to extract this because I have a feeling in the future this permute function, like there are going to be a lot of puzzles that expect me to get all of the permutations for a set of, objects or something. So we have our permute function. So it's going to be every permutation. Okay. So we want permute let guest permutations equals permute items guests. Right, so this should give me an array of arrays of guests, right? Yeah, it's gonna say it's not used. Yeah, show me. Why isn't it giving me a tooltip? All right, whatever. I'm pretty confident this is gonna be a guest, an array of arrays. Okay. So now the last thing I need is a table setting. I'm gonna give that a struct table setting. Maybe it should be a class. I'm gonna make it a class table setting, and in it. No, we need a var. Should it be a let? Let's make it a let. Guests. Guest arrangement. Guest arrangement is an array of guests. And so, guest arrangement guest. Oops. And this is going to take a self.guest arrangement equals guest arrangement. Okay. Okay, guest arrangement. And we're going to score the table. Score table. Okay. Okay, so what is my expected output? It's the maximum happiness value, right? Okay, that was the previous puzzle. Don't need it. Previous puzzle. Don't need it. Okay, puzzle input. So the what is the total change in happiness for the optimal seating arrangement of the actual guest list? Okay, so this is total, yeah, optimal seating arrangement. So maybe it'll ask me what the optimal seating arrangement actually is, but for now, let's just score the table and return the highest one. So the score is going to be for each index. Let's do, here we do score of func. Score of index, int. That's going to be an integer. And then for the index, if, so let adjacent guests, so we want, let's do var left guest equals, no, var left index, let's say that, equals, and then if index is greater than, so if it's, no, if index is 0, then the last index, and the last index is going to be guest arrangement dot count -1 or index -1. Okay, so that's going to be the index to the left of the person. Since it's a circular table and my array is a straight line, we're going to say the person at the beginning, at the head of the table, is going to be at 12 o'clock. Their person to their left, well, I'm going to say to the left is going to be this person over here. I'm going to say that person is index -1, which means I actually have to wrap around the whole table, and it's actually the last index. Okay, so that's the person to the left. Person to the right is going to be index number 2. So var right index equals index is greater than or equal to guest arrangement dot count. If that's the case, then the index is going to be 1. The index is going to return 0. Otherwise, index +1, right? Again, so if we're talking about the guest at this top left of the clock, the person to their right is actually index 0. They're going to be index 8 or whatever, and the person to their right is going to be index 0. So actually, we need to go all the way back around to 0. Okay. So then we're going to do score. So we're going to score this person at this index, and we're going to say, we're going to find the person, let this guest equals guest arrangement, guest arrangement index. And we're going to say let left score equals this guest dot friend score for the guest to their left. So we're going to do left guest equals guest arrangement left index. Let right guest equals guest arrangement right index. Okay, so we're going to do let left score equals this guest dot friend score, and we're going to find the name of the left guest. So left guest dot name, and we're going to do let right score equals this guest dot friend score right guest dot name. And I'm going to go ahead and put a bang operator on there. I'm going to put a unsafely unwrap because I'm feeling fairly confident that my guests are all going to be in the right place. Okay, and then we just need to return left score plus right score. Okay, so now if we're going to score the whole table, we need to accumulate all of the scores for every guest. So let guest scores scores equals guest arrangement dot enumerated dot map. I'm just going to return an array of indexes. It'd be $0, right? So this is going to be an array of indexes. Okay, what is 0 in this context? That is the element. No, so this should maybe be 1. $1. No. Ooh, no, that is the guest. enumerated sequence dot element. Okay. Oh, dot 0. There, that's what it is. Right, because the actual enumerated sequence is... Okay, so now we have that, and we're going to do dot map. We're going to map self dot score. Okay, and we're going to return guest scores dot reduce 0 plus. Oh, yeah, these should be constants. We're going to use let instead of var. Okay, build succeeded. Okay, so now we have our guest permutations. So I'm going to map the guest permutations to a list of table arrangements, table settings. So we're going to do let table settings. Table settings equals. We're going to do guest permutations dot map table setting dot init. Right? And then from the table settings dot, we're going to do let table scores. Table scores equals table settings dot map backslash dot guest. No. We're going to take the table setting. We're going to do score table. Score table. And then we're going to do, we want the highest one, right? So we're going to do let dot sorted. So starting at the low end and go to the last end, I'm going to do reversed. Okay. So that means the first index of this table score should be the highest. So I'm going to go ahead and return table scores index 0. What do you mean? No exact matches and call to subscript. Okay, weird that it didn't accept it the first time, but we're good. We're still good. We still got the first element. Okay, so now we're going to go ahead and run this. See if the tests pass. Ooh, look at all these passwords. Santa's passwords. Let's clear this. Okay, 13. So I'll make sure I have copied my puzzle input to the pasteboard. I'm going to turn it down a little bit. It's getting kind of loud. All right. Oops, that was not what I wanted to do. Shoot. Oh, okay, I'm update on my Z shell. Okay, 13. Let's get this back on, make sure this is on the pasteboard. Copy, run. Okay, compiling, merging, code complete. Uh-oh. Okay, index out of range. Illegal hardware instruction. Okay, so now we need to figure out where this is failing. So let's go ahead and print some statements. Print rules. No, print make rules. Map input. Print make guests. Print guest permutations. Permutations. Print table settings. Print score tables. And that should be it. So let's see where it crashes. Okay, so it's crashing at the score tables section. Okay, so that means let's do this. Print index. Oops, index. And we're going to do left index. And right index. And we're going to do, yeah. Okay, left 3, right 1. Okay. Oh, if index is greater than or equal to guessed arrangement.count, then the right index should be 0. Otherwise, it's index plus 1. So this one this was wrong. So index 3, left 2, that's correct. Right should be 0. So why is that 3? Oh, does this need to be greater than or equal to index count minus 1? Yes, it does. Okay, 733 is the answer. Come on. Yes, that is the right answer. You are 1 gold star, closer to powering the weather machine. Okay, perfect. Running tight on time. Let's see what part 2 is. In all the commotion, you realize that you forgot to seat yourself. At this point, you're pretty apathetic towards the whole thing. Your happiness wouldn't really go up or down, regardless of who you sit next to. You assume everyone else would be just as ambivalent about sitting next to you, too. So, you add yourself to the list and give all happiness relationships that involve you a score of 0. What is the total change in happiness for the optimal seating arrangement that actually includes yourself? Okay, so I'm going to create a static var me, and that is going to be guest, and var, so self guest name is me, and friend score. So if we want to get a friend score from a certain person, friend score, here we go, or 0. So that should do it. Now all I need to do for part 2 is test case, solve B. So I'm going to delete these print statements. So we have guests. So I'm going to make this guests variable a var, and then guests.append.me, right? So now that I'm in the list of the guests, and if anyone sits next, so I don't have any relationships to any of the other people, so it's going to be 0. It's going to default to 0. I think this should do it. So I'm going to go ahead and comment these out, just because I don't want to have to see the console burn up, and then this one too. All right, let's run it. It's going to be a lot longer because, by adding myself, the number of permutations, it grows by exponentially. Okay. Wow, it actually goes down. People would be better off without me. Wow. That kind of stings. Okay, that's the right answer. You 1 gold star, closer to powering the weather machine. I think that's cute. The reason that it's miserable is because of me. If I wasn't in the party, happiness would be 8 points higher. Wow. All right, that's it. Day 13. We made good time, 10:45. And I will see you all tomorrow, maybe, for day 14. All right, take care, everyone. Oops, this was wrong. This should have been 13. That's okay. Too late.